Since we've lost the class meeting to snow, instead of seeing me in person, you'll get to, well, not see me, but hear me on this video as we try to cover some of the topics we would have in class today. So first thing we're going to look at in section 2.2 is where functions increase, decrease, and are constant. And what we're talking about here is what's happening on our graph as our x values are increasing. So that's what this statement here is saying, that as our x's increase, moving from left to right, as our x2s get bigger than x1s, x3 bigger than x2s, as our x values are increasing, what's going on with y's? If, as we move from left to right, our y values are getting bigger, so our y values are increasing, our graph looks like it's going up. It looks like we're going uphill. Now, if we look at what happens when our x values are increasing, as we move from left to right, if the y values associated with the x's are getting bigger, so our x's are getting bigger, y's are getting smaller, then the graph looks like something like this. We're going downhill. So x got bigger, y got smaller. The third scenario is constant. And again, we're looking at what's going on here when x2 is bigger than x1. What's going on as x's are getting bigger as we move to the right along the x-axis. If the y values stay the same, we have constant behavior, which looks like a straight horizontal line. So what this graph says is, it doesn't matter what x is, y value will always be a certain number. In this case, maybe y is 3 or maybe 5, but it's a straight horizontal line. That's constant behavior. Taking a look at some examples, what we're going to do is we're going to look at the graph and we are going to decide what behavior do we see on this graph. And we're going to define this behavior in terms of our domain. In other words, we're going to break up our domain. We're going to divide up our domain into intervals that will describe where we're increasing, decreasing, or constant. The point I want to make here is that the intervals we're going to be using are going to be open intervals. In other words, we're going to be using parentheses because the end values of our intervals are not going to be included. We'll take a look at that in a minute. Let's take a look at this graph here, this function here. We don't have the equation for it, but we have the picture of its behavior. And we can see that we have some intervals that our function is decreasing. So here's one, and here's one. And we also have some intervals where our function is increasing. We are increasing here, we're increasing here, and we're increasing here. So let's describe these in terms of our domain. Let's describe these in terms of what's going on with our x-axis information. If we take a look at our first interval, moving from the left to the right, we don't have to do it in this order, I'm just choosing to. As I said, we're going down. So we're going down from here to this point here. We're not going to define it in terms of what the y values are. We're going to determine what happens in our interval using our x values. So we can see the arrow says we're x-wise, we're going on forever. We're also happening to be going on forever with y, but we're concentrating on x here. And we go down, we decrease till this point here, but we're not using this point to describe our interval. We're going to go up to that x-axis there and see that -1, -2, -3, -4, -5. We decrease until x is -5. Moving to the right from -5, from -5 we go up, we go up, we go up until this point here. Again, we're not going to look at the y value there. We're going to go down to that x-axis. X here is -2. So from -5 to -2, our function is increasing. Now, continuing on, from -2 we're going down. So we're decreasing until we hit this point here where x is 0. So we're decreasing. I'm going to use my little union symbol to show that from x being -2 to 0, we're continuing to decrease. Continuing to move from the left to the right. Our function is now going up again. We're increasing to this point here. Going down to our x-axis, we see x is 2 here. So we are increasing from 0 to 2. Continuing on, our function is now going down. We're decreasing. We're not going to use this point here. We come up to that x-axis to find the value we use to describe our interval. So we are decreasing here from when x is 2 to when x is 5. I want to point out here, notice when x is 5, here we have this point here where x is 5. I don't use that. It's in the parentheses because here at this point, we're really not decreasing anymore and we're not increasing anymore. At that particular point, what we're doing is turning around. So it's neither increasing nor decreasing. It's a turning around point. Last but not least, from here to here, our function is increasing again. So from where x is 5, and then we see we go on for infinity, our function is increasing. So we've accounted for our entire domain, and nowhere did we notice any behavior where our function was constant. So constant, I'll put none. There is no interval where our function is constant. Another example of the same behavior. We can see here that we have some constant behavior where our function is flat. We have an interval where our function is decreasing, and then we also have an interval where our function is increasing. So this particular example, we're going to see all three kinds of behavior. I'm going to start with the constant behavior just because we didn't see any in the last example. So here, our y value is the same. So as we increase here in x's, our y just stays the same. So that represents constant behavior. And we can see we go from infinity here. We just continue to go into negative x territory. And we stop here when x is -3. So we are constant from x is -infinity to -3. We also see another interval where our y value is flat. We have the horizontal line, and this one occurs from this x value to the right. X is 2 there, so we are constant from 2 to positive infinity. There are our two intervals of constant behavior. Now let's see about decreasing. So looking at our graph, we can see that we are decreasing, our function is decreasing in this interval right here. So from where x is -3 to where x is -2. In terms of x, it's not a very big interval. That doesn't matter. Our function is going down. And last but not least, let's take a look at where our function is increasing. Here we can see that from here to here, in this interval here, our function is going up. In terms of x values, we are going from where x is -2 to where x is +2. So there is our interval that describes where we're increasing. I just want to point out that if we look at this particular example, we can see that the domain of this function here is -infinity to positive infinity. We go negative, positive infinity. When we look at our intervals of activity, we've broken up our entire domain and accounted for our entire domain in terms of these intervals. We've gone from -infinity to -3, -3 to -2, -2 to +2, and then finally 2 to infinity. So we've accounted for our entire domain, now described in terms of where we're increasing, decreasing, or we've stayed constant.